You won't believe what scientists heard when they pointed their instruments toward the darkest corners of the universe. It's a sound that, according to everything we know about physics, simply should not exist. Space, as we've always been taught, is a vacuum. A silent, empty void where sound waves have nothing to travel through. So how could we possibly hear anything from it? This isn't science fiction, it's a real-life cosmic mystery that is forcing us to question the very nature of reality. For decades, we've sent probes and telescopes into the cosmos, listening for signs of life, for echoes of the Big Bang, for anything that could tell us more about our place in this vast expanse. The Voyager probes carried golden records, a message in a bottle for any civilization that might find them. The SETI project has scanned the stars for alien radio signals for over half a century. We were searching for a signal, a pattern, something intelligent. But what we found was something far stranger. Something that came not from a distant star system, but from the seemingly empty space between galaxies. The story begins with our understanding of sound itself. When a bell rings, it vibrates, pushing the air molecules around it, creating compressions and rarefactions that travel to our ears. In the near-perfect vacuum of space, there are so few particles that this kind of transmission is impossible. It's the ultimate silence. That's why in movies, when a spaceship explodes, it should technically be completely silent. But space isn't entirely empty. It's filled with a very thin, tenuous plasma, a superheated gas of charged particles. These particles are incredibly spread out, but they are there. Scientists have known for a while that these plasmas can carry waves, similar to sound waves, called plasma waves or magnetosonic waves. These are not sounds you could hear with your own ears if you were floating in space without a helmet. They are electromagnetic vibrations that our instruments can detect and then translate into audible frequencies. For years, we've recorded the sounds of planets like Jupiter and Saturn, which have powerful magnetic fields that create these eerie whistles and chirps. While profound, this was still within the realm of explanation. A black hole was creating pressure waves in a gas cloud. But that wasn't the sound. Voyager's instruments were picking up a persistent, low-frequency hum. A steady vibration in the sparse plasma of interstellar space. It wasn't coming from the sun or from any planet. It was just there. The sound of the empty space between the stars. It was like tuning a radio to a station where there's no broadcast, but you still hear a constant, low static. Except this wasn't random static. It was a coherent, persistent hum. This is where the story takes its twist. This sound shouldn't be there. The interstellar medium is incredibly thin, with only a few atoms per cubic centimeter. What could possibly be causing this entire medium to vibrate in a steady, constant drone? The sun's influence, the solar wind, creates a bubble around our solar system called the heliosphere. Voyager 1 has crossed the boundary of this bubble into interstellar space. Scientists thought that once it was outside this turbulent boundary, things would get quiet. Instead, they found this hum. Theories began to fly. Some suggested these were thermally excited plasma oscillations, tiny, localized vibrations in the plasma that, when added up over vast distances, create this background hum. It's like the faint, collective murmur of a massive, distant crowd where no single voice is clear, but the sound of the crowd is constant. This is the most widely accepted scientific explanation, but it's still a hypothesis. It doesn't fully account for the steadiness and persistence of the sound. It's a plausible guess, but not a definitive answer. Other, more speculative ideas have been proposed. Could this hum be a faint, residual echo from the Big Bang itself, a different kind of cosmic background radiation that we're only now able to detect? Could it be caused by the interaction of dark matter particles, the mysterious, invisible substance that makes up most of the matter in the universe? We know almost nothing about dark matter, except that it has gravity. Could it also have other, more subtle properties that create these vibrations in normal matter? This is where we move from known physics into the realm of speculation.